Guys, go ahead and pull up the 3-3-3-4 notes. We're going to do, I don't know how far we're going to get today, but in the next 2 days, we're going to do this lesson. It's a combined 3-3 and 3-4. And then on Friday, you'll have time to work on test review. I'm going to give your quizzes back probably tomorrow. I think Miss Carver or Thompson has makeups this afternoon. But I'll give them back so you guys can go over it. And then we're going to test next Tuesday over 3-1 to 3-4. It's at the beginning of HOCO week, so we should be okay. All right, we're going to go over a few things today, calculator-wise. We're going to talk about condensing and expanding, and then we're going to talk a little bit about solving, and we'll finish solving up tomorrow. But in your calculator, guys, everybody has a log button. Find your log button. The log button in your calculator is log base 10. It says log. It's log base 10. That little number there is 10. That's what's programmed into your calculator. If you don't see a little number there, it's considered log base 10. Same thing with the ln. We'll talk about that in a second. But sometimes you guys are going to be given stuff and you have to use the change of base formula. Some of your calculators do it for you. Some of them don't. But if you were going to try to figure this out, right, we think exponentially. So I would rewrite this as a big 4, right, to the x power equals 25. Do you guys know in your head what you would raise 4 to make 25? No, that's why you need your calculator for stuff like this. You guys can't do this. So you have to evaluate using the change of base. And it's really simple. The way that you do that is in your calculator, you hit log of the big number divided by log of the little number. Now, when I say big and little, which one is the big number, guys? 25 is the big one. Which one is the little one? Yeah. It's not necessarily the larger value. It's visibly which one is bigger. So you would hit in your calculator, you'd hit log 25 divided by log 4. And what do you get? Round it to 3 decimal places. 2.322. Okay. If you're not getting that, you need to let me know. Everybody okay? So if they tell you to evaluate using the change of base, that's what they mean. So how would you write this one? Log what? Log 12 divided by what? Log 2. Perfect. What do you get? 3.585. Okay. All right. Super simple. You're going to need that when we go to solving. Now, on your calculator, guys, on your log button, right, we have our log button. What's above the log button? Like if you were to hit second or shift, what's the inverse? What is it? 10 to the x. So logs and exponentials are what of each other? Inverses. How do you undo? You're going to use the inverse. You're going to need that when we go to solving. So same thing. Now we're going to use the natural logarithm. You guys have the ln button? Okay, what's the inverse? What's on top of ln? E to the x, right? Okay, so these are both, this is a log function and an exponential. It's just a specific one. So it's the exact same thing. If you guys were going to use the change of base here, instead of log, they want you to use natural log. So do ln of 25 over ln of 4. What do you get? Excuse me. 2.322. 2.322. And then do the same thing here. Natural log. Natural log 12 over natural log 2. What do you get? 3.585. Is that the exact same thing we got when we used just the regular logs? So just to show you, logs and natural logs they're not different. It's not two different things. It's just natural log and e to the x are specific to each other. Anytime you have an e to the x, the only way to do the inverse is the natural log. You can't use the logs, but we'll talk about that more in a minute. All right, we're going to talk right now about condensing and expanding. What does it mean to condense? So God bless you. Make smaller, smush together is what I'm going to say. What does it mean to expand? To make bigger. So we're going to condense, smush together, or we're going to expand, pull apart. All right, so let's talk for 1 second. What is the opposite of, well, in a minute. Look at your product property. There's three properties to look at. What is going on? Now, but look, natural log and logarithm, same thing. What's going on here with u and v? They're being multiplied. So do you guys see that u and v are smushed together? So if you were going to pull them apart, what would you use instead of multiplication? Addition, okay? When you pull apart, each piece of the problem gets its own log. And if it's being multiplied, when you pull it apart, multiplication becomes addition. So what do you think happens when you're starting off with addition and you're going to smush it together? What does your addition become? Multiplication. Okay, so let's look at the second property. And this will make a little more sense when we do a couple examples. What's going on with u and v here? Division. So if you are smushed together, dividing, when you pull it apart, what does division become? Subtraction. Okay? And then your product property. I want you guys to notice this. What's going on here? I have u to the n power. And then where does the n go? When you pull it apart, where does the n go? To the front. So your exponents become coefficients. So if you're smushed together and you're pulling apart, your multiplication becomes addition, division becomes subtraction, and exponents become coefficients. If you're already pulled apart and you're smushing together, then your addition becomes multiplication, subtraction becomes division, and coefficients become exponents. So let's do a couple of these. Don't worry about these. Let's go to the next. All right, on your test, it will say condense or expand. You have to figure out what you're doing. So look at how we're starting off here. I have one log and everything is smushed together. So we're going to pull it apart. So that means every single piece gets its own word log. So let's go. Let's do A. We'll do this together. So A. I like to look at this and say, okay, what's going on here? What's happening between 5, X, and Y? They're all being multiplied. So when I pull it apart, what am I going to write instead of multiplication? Addition. Good. And I have a 3. That's an exponent. Where is that going to go? To a coefficient. So watch. Everything gets its own log. So I have log base 4 of 5. Multiplication becomes addition. I have log base 4 of x cubed. Multiplication becomes addition. So I have log base 4 of y. Everybody with me? Now I have one more thing I can do. I got rid of my multiplications, but what do I have to do with this 3? I have to put it in front of that log. Not to the front of the whole thing, it's just the front of that log. So when I pull this apart, it's log base 4 of 5 plus 3 log 4 of x plus log 4 of y. When you pull apart, every single piece, whether it's a number or a letter, gets its own log. Multiplication becomes addition. Division becomes subtraction. Exponents become coefficients. So look at B, natural log. All right, there's a few things going on here. First of all, let's look at B. I have the natural log. What's another way I can write the square root of as an exponent? 1/2, good. Anytime you guys see a radical, if it's a cube root, it's 1/3. If it's the 4th root, it's 1/4. But remember, we're working with exponents, so you need to go ahead and fix that. So I see some things here. I see some things. If I'm going to pull this apart, what is my division going to become? It's going to become subtraction, right? And then what is my exponent going to become? A coefficient. Give yourself a little map. I'm going to pull this apart, every piece gets its own ln now. You're not going to write log, you're going to write ln. So I'm going to write ln of 3x minus 5 to the 1/2. And then what sign? Minus the natural log of what? 7. There you go. And then I have one more little thing I can do. What do I do with this 1/2? I bring it in front. So it's 1/2 ln 3x minus 5 minus the natural log of 7. That's it. When you pull apart, everything gets its own, either natural log or log, whatever little base it says. So now we're going to do the exact opposite. This is already pulled apart. What are we going to do? We're going to condense it. We're going to smush it together. So let's just look at what you have here. I have a 1/2 and I have a 3. What are those both going to become? Exponents. Good. So tell yourself that. That's an exponent. That's an exponent. What is this plus sign going to become? Perfect. Multiplication. So you're kind of telling yourself what to do. So I have a. How many times am I going to write log little 10? Just one time out in front. So I have log little 10. So the first thing I'm going to do is move this here. So I have x to the 1/2 times. I'm going to move this here. And then I have x plus 1 to the 3rd. Everybody with me? You do not have to multiply anything out at all. Don't foil x plus 1 times x plus 1 times x plus 1. What do we need to simplify, though? We're not going to leave rational exponents. So log little 10, what's another way I can write x to the 1/2? Square root of x, good, times x plus 1 cubed. You're just pulling apart, smushing together. If it's already pulled apart, you write the log one time out in front and then smush everything together. Look at B. What's 2 going to become? Exponent, good. What is my minus sign going to become? Division, good. Whatever, it's subtraction. So think about it. What do I write one time out in front? ln. All right. So I have, what's in my numerator? X plus 2 what? Squared divided by x. That's it. Make sure the ln is out in front. It's not in the numerator. It's not in the denominator. It's out in front. All right, letter C. What do you guys notice, excuse me, about the 1/3? Where is it placed? In front of everything. So that is going to become my exponent of the entire thing. So make sure you see that. If I have something raised to the 1/3 power, what root is that? Cube root, okay? So I have log little 2, log little 2. What is this going to become? Multiplication. So let's write that out. So for C, I have log little 2. So I have x times x minus 4, all raised to what? To what? The 1/3. If you want to multiply it, you can. You don't have to. You can go ahead and write log little 2 x times x minus 4. How do I write 1/3 power? The cube root. Perfect. If something is already pulled apart and you're smushing it together, addition becomes multiplication. Subtraction becomes division. And coefficients become exponents. All right, you guys okay? All right, we're going to go to a little bit of the solving. I want to try to get through as much as I can so we don't have a ton to do tomorrow. Excuse me. You guys do not have to memorize all of these properties or anything like that. But I want you to notice, do you see where it says properties on the far right? 1-to-1, 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 1-to-1. What does it mean 1-to-1? The left-hand side and the right-hand side bases are the same. So look, you can solve this first one, 1-to-1, by writing both sides with the power of, or to second power. How can we write this one? What did they do here? They moved this one to the other side, right? Because it was set equal to 0. You're allowed to do that, absolutely. Here, they moved this to the other side. Here, we got the same base. The problem lies, guys, when you are here. The only pre-cal step that you guys are going to do, actually, I don't even think it's pre-cal. I think some of you did this last year in algebra 2. But we're solving equations. How do you solve equations? You use order of operations backwards, right? If you're multiplying, to undo it, you divide. If you're adding, to undo, you subtract. If you're squaring something, to undo, you take the square root. So we have to remember that logs and exponentials are what of each other? Inverses. That's the one step that you have to remember in solving to get your x all by itself. So that's what we're going to do. We're just going to solve all these. All right, let's look at A. You have to have your calculator here. You have e to the x equals 72. The first thing you need to do is isolate. You want to isolate your function, whether it's exponential or logarithmic. I have e to the x. As soon as I see e, what do I think the inverse is? Look at your calculator. What's on the same button as e? ln, okay? So at some point, you're going to need to take the natural log. Is e to the x all by itself? Is anything being multiplied or added or anything to it? No. So how do I undo e to the x? Not multiply, but you're going to take the natural log. So what you do to one side, ln of e to the x, you do where? To the other side, so ln of 72. What happens on the left-hand side with the ln and the e? They cancel, so x equals, calculator, 3 decimal places. What are you guys getting? 4.277? Okay, so 4.277. Now, every single one of these problems, the great thing about this is you can check. In your calculator, excuse me, take this number and plug it in right there. So hit your e to the x and put, as the exponent, 4.277. Check that, see what you get. Now, sometimes, guys, you'll get the exact answer. Sometimes you won't. It'll be really, really, really close. You might get like 71.9999999. I mean, obviously, we have to round, so it's not going to be perfect. But you guys, when you turn your test in, you should know all of the solving ones if you got them right or not, because you can check every single one of them. This is a lot of calculator work on this test. So let's look at B. All right, I have 3 to the 2x equals 42. Okay, so the first thing I like to do, I like to highlight my function. And then I say to myself, what kind of a function is this? Is this exponential? Is this logarithmic? It's exponential. So what's the opposite of exponential? Logarithmic. So at some point, you're going to have to take the log. Right? You understand that? So I have to get my 2 to the x by itself first. I'm going to divide both sides by 3. Perfect. So I have 2 to the x equals, what's 42 divided by 3? 14. Okay. Now, my 2 to the x is all by itself, so I have to undo it. What's the opposite of exponential? Logarithmic, okay? So if I was going to use a log, what would my little number be? Very good. Whatever the big base is, guys, that's what you're going to use to undo. So I have log 2 of 2 to the x. What you do to one side, you do where? To the other. So you have log 2 of 14. So on the left-hand side, what happens with log little 2 and big 2? They cancel. So I have x equals. How do I put this in my calculator? Log what? Log 14, perfect, over log 2. And then round. Give me 3 decimal places. 3.807. Now, go ahead and check that. Take that number and plug it in right there. In your calculator, hit 3, parenthesis 2, raise it to the 3.807, close your parenthesis, and it equals. What do you get? What do you guys get? All right, let's go to example 3. Again, guys, we're just solving equations. You guys are really good at solving equations. We are very good at solving equations. Keep telling yourself that, right? We got this. So I'm going to isolate my function. I want to show myself what I'm trying to get by itself. So I have an e. What am I going to use at some point in my problem if I'm trying to undo the e? ln. Good. You should always tell yourself that at the very beginning, and then you won't get yourself lost. So I have to get that e to the 2x by itself. So what would I do? I'm going to add 3. Perfect. So I have 4 times e to the 2x equals 5. Again, I want to get my e to the 2x all by itself. So what do? Divide by 4. Perfect. So I have e to the 2x equals 5 over 4. Just leave it. Don't simplify or anything like that. Just leave it. Okay, now that my e is all by itself, what is the only way that I can undo that? ln. So what I do to one side, I have to do where? So I'm going to take the ln of e to the 2x equals the ln of 5 over 4. Got to put 5 over 4 in parentheses, guys. On the left-hand side, what happens with your e and ln? They cancel. So you have 2x equals, what's the natural log of 5/4? 0.223. Is that what you guys got? And then my last step is to do what? Divide by 2. So x equals 0.11. And then what can you do with that? You can throw it back in. In your calculator, hit 4, then e, raise it to the 2 times 0.112, close the parenthesis, minus 3, and you should get something really close to 2. Solving isn't bad. You just have to remember what the inverses of each other are. All right, go. Keep going. I'll get through these examples, and then tomorrow, well, I don't know. We'll see. All right, first of all, I'm going to change my t to an x because, you know. All right, I'm going to isolate my function. I'm going to bring it to light so I can see what I'm trying to get by itself. What kind of a function am I starting off with? Is this a logarithmic or is this an exponential? It's exponential. So I want to get that by itself. What are the 2 things I have to do first? I have to add 4. So I have 2 to the 2x minus 5 equals 15. Now what? Divide by 2. Perfect. So I have 3 to the 2x minus 5 equals, I'm just going to leave it as 15 over 2. Now I have my exponential completely by itself. How do I get rid of an exponential? What's the opposite? Log. So I'm going to write log and put a little, what number? Perfect. I put a little 3 there because then I have a big 3 in my problem. So if I take the log base 3 of the left-hand side, then I have to do what? Log base 3 of the right-hand side. So on the left, guys, what happens with log little 3, big 3? They cancel. So you have 2x minus 5. And then in your calculator, how would this look? Log of 15 over 2 divided by log 3. Again, some of your calculators have the change of base formula in it. Some of them don't. But now you're going to get a wonky decimal. Don't truncate it to 1 decimal place. Give me at least 3. Log of 15 over 2. 1.834. So 1.834. You guys agree? Yeah? All right, now, can we all solve this equation? Yeah. What do? I'm going to add 5. Perfect. So I have 2x equals 6.834. And then do what? Divide by 2. Perfect. So x equals 3.417. Can I check that? Yeah. Just plug it back in for x. Or in this case, I know it says t. All right. We're still solving. Let's look at A. Let's look at A here. It says ln of 3x equals 2. Guys, notice. where the 3 is. Is the 3 out in front being multiplied? No, it's part of the natural log. That's why I like to highlight it here. There's nothing, you can't divide both sides by 3 or anything like that. The 3 is in between the natural log and the x, so it's together, it's stuck there. So I look at my calculator and I say, okay, what's on the same button as ln? E. So if I'm going to get rid of this ln, what do I have to do? I have to say e, and then I'm going to put this in the exponent, ln of 3x. We're undoing. So the opposite of ln is e to the x. So what you do to one side, guys, you do where? So I put a big E, and where does 2 go? To the exponent. Good. So on the left-hand side, what happens with E and ln? They cancel. So you have 3x equals, what's e to the second power? 7.3, what was it? 389. Okay, thanks. And then I'm going to divide both sides, excuse me, by 3. And what does x equal? 462? 463, thank you. My ears are clogged. I was in bed all weekend. Can I check this? Yeah. All right, let's look at B. So I have log 3, 5x minus 1 equals log 3 of x plus 7. All right, I have a log on one side and a log on the other. Do you have one log base 3 on the left and one log base 3 on the right? Yes? So what can you do to those? You could just cross them off. Because think about it, guys. What's the opposite of log little 3? Exponential, right? So if you made this a big 3 over here and a big 3 over here, it would cancel. If you have one log on the left-hand side that's exactly the same as the one on the right-hand side, you just cross them out. So now do we all know how to solve this? 5x minus 1 equals x plus 7. I'm going to move x this way. I'm going to add 1. So I get 4x equals 8. What's x equal? Okay, x equals 2. Now, this is a different kind of problem here because we started off with a log, right? When you start off with a logarithmic, the other ones they were all exponential. But when you start off with logarithmic, you got to be careful with your answers. Everybody right now, in your calculator, hit log -7. What does it say? Error. Okay. Hit ln of -12. What is it? It says error. Okay. What can you deduce, guys, about natural logs and logs? You cannot take the log of a negative number. So cannot, write that down. Cannot take the log or natural log of a negative number. So why am I telling you that? Well, what do we need to do if we start off with a log equation, right? Start off with the word log here. What do I need to do with my x just to make sure it doesn't happen? I got x equals 2. What should I do with that 2 to make sure that this does not become an error message in your calculator? Plug it in. You got to make sure that whatever x value you get does not make your log negative. If it does, then it's no solution. So if I put a 2 right here, what's 5 times 2? 10, and 10 minus 1 is, so log 3 of 9, we're fine. What about over here? 2 plus 7 is 9, so this is log 3 of 9. We're good. If you were to plug that in and one of the logs became negative, that immediately doesn't work. Just got to check that. All right? Isolate, highlight, circle, whatever you need to do. But there is my function. ln, what's the opposite of ln? E. So think about that. At some point, you're going to use e to the x. But I have to get the ln by itself. So what do I do first? Subtract 5. Perfect. So I have 2 times the natural log of what? -1? Yes? Okay, and then what do? I'm going to divide by 2. So I have the natural log of x equals negative 1/2. All right, I have the natural log all by itself, so I've got to undo it. How do I get rid of natural log? I'm going to write a big E, and then this goes into the exponent. So what I do to one side, I do where? To the other. I'm going to write a big E, and then my negative 1/2 goes in here. So what happens with E and ln? They cancel, and I get x equals. What is e to the negative 1/2 power? (606) Okay, perfect. 607? Okay. 606, 607, that's okay. Does everybody hear what Anna just said? Anna, move this to here because coefficients become what? Exponents? Same thing. Yeah. Mm-hmm. All right, let's go ahead and do the last page. Let's just get it all done and then we can work tomorrow on website stuff. God bless, God bless, God bless. All right, so let's go ahead and highlight. You guys see that 3 is stuck, right? Stuck in between, so you can't separate it. At some point, how are you going to undo log little 5? ln and e go together. What's the opposite of log little 5? Exponential with a big what? What's the big number going to be? 5. Good. So let's go ahead. Excuse me. Let's go ahead and get the log by itself. So I'm going to divide both sides by 2. You guys agree? Okay. Divide by 2. So I have log 5 3x equals 2. So we just went through this in our minds. What is the opposite of log little 5? Big 5. So I'm going to put a big 5 here, and this goes in the exponent. And what you do to one side, you do where? To the other. So I put a big 5, and what's my exponent? 2. So on the left-hand side, what happens with 5 log 5? Cancel. So 3x equals 25. And then I divide both sides by 3. So x equals, was it 8.333? There you go. Easy peasy. All right, so here we're looking at this and we're like, well, can I just cross them out? Can I just cross the ln's out exactly how this is written? No, why not? You have to have 1 on the left-hand side and 1 on the right-hand side. Can I do anything to this left-hand side to write this as just 1 natural log? Can I condense it? Yeah, I can rewrite this. I can write ln 1 time. And then what does this addition sign become? Multiplication. So this becomes x minus 2 times 2x minus 3. How can I condense the one on the right? I can say this becomes x squared. All right, perfect. Now I have 1 natural log on the left, and I have 1 natural log on the right. So what do I do to those? I cross them off. And now this becomes an algebra problem. FOIL, x times 2x is 2x squared. X times negative 3 is minus 3x. Negative 2 and 2x is minus 4x. Negative 2 and negative 3 is positive 6, okay, equals x squared. Combine like terms and then move the x squared over. So if I move this x squared over and combine these, I have x squared minus 7x plus 6 equals 0. We solve this? What are the factors of 6 that multiply to give me 6 but add to give me a negative 7? X minus 1 and x minus 6. So x equals 1 and x equals 6. So you got 2 answers here, but what do I have to check? I have to make sure that the natural log in the original problem does not become negative. So if I put 1 right here, what is 1 minus 2? -1. So is this one going to work? No. Cross it off. What about if I put 6 in here? What's 6 minus 1? Sorry, 6 minus 2. Perfect, not negative. What's 2 times 6 minus 3? Not negative, right? So then this one does work. So in this case, one solution works, one doesn't. But you have to check that. And then here's a little bonus. There's a couple of these. You'll have this on your test. It's also on Web of Science once you guys see it. Looks a little funny, but after I explain it, you're going to be like, oh, super easy. This isn't just 1 e to the x, right? It's not that we can just isolate it. This is a factoring problem. This is a factoring problem with exponentials. All right, so let's talk for 1 second. If I was multiplying e to the x times e to the x, right? If you're multiplying same bases, you keep the bases the same and do what to the exponents? You do what? You got them. So x plus x is 2x, right? That's where this comes from. So when you have a quadratic, this is a quadratic exponential problem. You're going to put it into 2 binomials, just like we just did. What's going to go to the front of each parenthesis? E to the x and e to the x. And now let's factor it. What are the factors of -6 that multiply to give me -6 but add to give me -1? -3 and +2. So what you have now, guys, is 2 teeny tiny e problems. I have e to the x -3 equals 0, and I have e to the x plus 2 equals 0. These quadratics will always work out. You'll always be able to factor them. You're never going to do the quadratic formula with exponentials or anything like that. But if you were going to solve the one on the left-hand side, you guys agree that we're going to move the 3 to the other side? So you have e to the x equals 3. On the right-hand side, you're going to subtract 2. So you have e to the x equals -2. I have one last step to do. How do you undo e? ln. So I'm going to take the ln of e to the x here, ln of 3. What you do to one side, you do to the other. So what happens with ln and e? They cancel, so x equals, what's the natural log of 3? 1.099. Perfect. Okay, same thing on the other one. How do you undo the e? ln. So I'm going to take the ln e to the x. What you do to one side, you do where? X equals, what's the natural log of -2? It says error, right? Can't do it, so what's your answer? You just have one answer here. Sometimes you'll have one answer, sometimes you'll have two answers, sometimes neither of them will work. But remember, you can't take the log or natural log of a negative number.